Hello and welcome to Circuit Stream's Introduction to XR Sound Design. Thank you everyone for joining us for another exciting workshop and webinar here. Now I do, as always, want to make sure that you can all hear me and see me. So please let me know in the chat box to the right. Can you hear me and see me? Yashna, hello Yashna, good to see you. I see yeses. Luke, I see you there. Alden, Adrian, perfect. Thank you everyone for letting me know. We have a super exciting workshop and webinar planned today. We have a special guest who I will introduce here shortly. I'm really looking forward to it. Now, as always, a few housekeeping items. To the right, as you can see, there is a chat box. So feel free to mingle amongst yourselves, add your LinkedIn profiles, network, chat, joke around, whatever you would like. The chat is all yours there. You will also notice a questions tab. Now, if you have any questions, please toss them into the questions tab. It's easier for us to keep track of and to answer. We will have some colleagues backstage answering some of those questions throughout the workshop. And at the very end of this presentation, we will have an in-depth question and answer session to help answer some of the things that we may have missed throughout the webinar. We will also toss in polls throughout the workshop and webinar just to gauge the experience of the audience. So feel free to answer those polls. It will give us a better idea as to how to tailor the workshop and webinar as we go on. Now, again, thank you all for joining us. I myself am located here in Calgary, Alberta. That's where Circuit Stream is headquartered out of. Let me know in the chat, whereabouts are you currently located? We have people joining us from all over the world for these workshops and webinars. Dale Campbell, nice to see you from Iowa. I see people from Italy, Toronto, Vancouver, Australia, Germany, Portugal, Austria, New Zealand. Ali, I see you. Good to see you. Iceland. So people, again, from all over the world, West Africa. A pleasure to have you all with us. Now, I do want to let you know, for those of you located abroad, we will be recording this workshop and webinar and sending it out to everyone who had registered. So if it is very late for you or early in the morning, don't worry. We will send everyone the recording and the assets as soon as it wraps up. So before I dive into it, I will take about 5-10 minutes, maximum 15 minutes, to introduce you to who we are and what we do here at Circuit Stream, which will then lead into our special guest presentation, going into XR sound design, showing you the fundamentals around designing, implementing, and shipping sounds for your XR experiences in Unity. So, my name is Stephane, and I am the education lead here at Circuit Stream. I have over 5 years of experience in the tech industry, working with learning management systems, business integration platforms, travel IT technology, and now in the world of virtual reality and augmented reality. A little icebreaker, in fact, about myself for those of you who are new here. I was a member of Water Polo Canada and trained with the 2008 Beijing Olympic team. Never went to the Olympics. Great experience nonetheless. And today's special guest is Travis Fodor. Travis is the technical sound designer at Microsoft, an athlete as well. 7 years of audio and sound experience working with Microsoft for a few years, and previously with AltSpace VR. It's truly a pleasure and an honor to have Travis join us. He's a great guy, super knowledgeable about this, and I'm super excited to listen to his presentation and see what he can go into with XR sound design. Now, a little icebreaker, in fact, about Travis. He was the top 50 in the world in 2019 for the Ironman distance triathlon for the 25 to 29 age group. Now, you know, that's blows my mind. He's an athlete, a monster himself, and really, again, a pleasure to have you with us, Travis. Looking forward to the presentation there. Now, a little bit about Circuit Stream. So Circuit Stream was founded in 2015 when everyone was on the hype train for building applications and VR AR projects. We noticed the gap in actually helping people learn how to develop VR and AR applications. So since 2015, we've taught over 30,000 people how to develop and manage these applications in Unity. We're a team of about 20 people located around North, South America, as well as Asia. And we are professionals in Microsoft platforms, HoloLens devices, Magic Leap, Unity, Unreal creation engines. So we're more than happy to shed some light on with anything else. Now, CircuitStream is a Unity certified training partner. Training partners are approved based on their expertise, focus on quality education, and commitment to providing the highest level of training available. CircuitStream is also an official channel partner with Unity to deliver training and application development services in the architecture, engineering and construction, automotive, transportation, and manufacturing markets. Now, there's three things that we really focus on here at CircuitStream. The first is education and training. We typically teach these people through our XR development with Unity course, and these are just some of the professionals we've had the pleasure to join us. Our XR development with Unity course is all live and online. It's 10 weeks long, 4 hours a week. And if you are interested in diving deeper into this, September 28th is our next course. Feel free to reach out. We'd be more than happy to talk to you about that. Now, what differs us from any of the other providers out there is the one-on-one support, where we help you build your own project, idea, work on a challenge or an issue that you are interested in. And by the end of the program, you have something to show for, to add to your portfolio, a prototype. Now, the second thing that we do at CircuitStream is XR content creation. So we actually build VR and AR applications and projects for companies around North America. And these are some of the partners that we're super excited to be working with implementing this technology. The third thing that we do at CircuitStream alongside training and education, as well as content creation, is an XR platform that allows people to host their AR and VR applications on, scale, distribute, and manage applications, as well as track, measure, and analyze learning activities. So I will toss in a quick 2-minute video here for those of you who haven't had the chance to check out our CircuitStream platform, and I'll be right back.
Welcome to CircuitStream. Since 2015, we've taught over 25,000 people how to build innovative XR applications. Now, we're bringing everything that we've learned together into the CircuitStream platform, a central portal for everyone in your organization to experience, distribute, and even create XR content. Log into the platform and you'll be able to launch and experience your organization's XR applications with the click of a button. Our CircuitStream Hub removes all the friction of installing and updating apps by handling everything automatically in the background so your employees don't have to. While users are in XR, we capture data from the application, allowing managers to track usage, structure pilot projects, and express ROI to stakeholders. Working together with CircuitStream, we can build analytic views around your key performance indicators and the unique problem sets that you are tackling with XR. Managers can set up and control access across the organization as you expand and scale your XR applications to train employees, communicate ideas, or do something amazing that no one has even thought of before. Our goal is to give you the tools for innovation. If you have XR developers within your organization already, they can also use the platform to upload their own applications and manage them efficiently by publishing updates and tracking quality assurance issues. The CircuitStream platform is built to manage and scale across the organization, whether you are creating your applications internally or working with an outside vendor. Start experiencing, building, and scaling XR today with the CircuitStream platform.
Wonderful, wonderful. So with that, now that you've learned a little bit about us, what are you going to learn today? Today, you'll be learning how to record sounds with editing tools, how to implement these sounds in Unity, Unity's native sound capabilities, and the best practices for implementing sound design in your XR environment. Now, I do want to toss in a quick poll here. I always like to see how much Unity experience do you have on a scale of 0 to 10. So I just tossed in a poll in the polls tab there. Let me know how much Unity experience you have. I'm always very curious. It looks like we have a lot of beginners, quite a few zeros, some ones, twos. We have some professionals here as well, some sevens, eights, and tens. So that's great. A nice mix of experience here on the workshop and webinar. Now, for those of you who answered 0, what is Unity? Unity is a free 3D development engine for building games, simulations, and experiences. It's the easiest way to begin making apps for XR. Now, XR stands for extended reality. It's the umbrella term for VR and AR, augmented reality and virtual reality. Now, how does one actually go about creating their own projects and applications in Unity? Well, you have an idea and you bring that idea into Unity where you develop it and optimize it. Once that's created, you push it out to one of the available SDKs like the Microsoft HoloLens, for instance, and then pushes out to the relevant device there. Now, we're talking about sound and audio design today. And I want to introduce you briefly to sound and audio design before Travis joins us and leads the design part there. So immersive audio is 360-degree audio that mirrors real-world soundscapes within XR experiences. Sounds emanate from all directions and are non-linear. For example, if you see a dog barking to your right in a VR simulation, immersive audio will match the location of the barking sound with the dog's visual location as you move around the virtual space. No matter how good motion controls or graphics within VR and AR get, true immersion cannot be achieved without paying attention to psychoacoustics. Psychoacoustics essentially defines how humans perceive sound. Audio acts as the door into interactivity, and the ability to localize directional audio helps users feel as if they have control over their environment. So the longer an illusion of realism is maintained, thanks in part to object-based auditory cues, the longer a user remains in the headset so long as their immersion is uninterrupted. Now, audio in AR and VR is said to be 51% of the experience. As in real life, when you look around, your field of view is limited, but you're still hearing the full 360 degrees sound field around you. So it needs to be realistic to not pull you out of the experience. Spatial audio is important for all VR AR experiences. Research has shown that spatial audio keeps users in an experience for 40% longer. So you want the sounds to mimic real life and add realism, immersion to the experience, whether it's entertainment or enterprise applications. But enough about me. Today is an intro to XR sound design. Now, I will invite Travis here shortly to get going on his section there. I will drop a quick video here just to hype you up as Travis is making his way on stage to see what you can do with some devices like the Magic Leap in terms of audio and sound. So here's a quick minute video just to show you there. Right on. Well, I hope you guys enjoyed that. Definitely hyped me up. Again, it's truly an honor and a pleasure to have Travis Fodor join us from Microsoft to talk more about XR sound design, how to think about it, implement it, manage it. Again, I did see some comments here. If you have headphones, put on headphones. I know Travis is going to share some stuff here. You'll get more out of it. You won't be held back, but you'll feel the experience to its full potential. So Travis, take it away. It's a pleasure to have you, and I'll join you guys again here shortly.
Thanks, man. Hey, everybody. Thanks so much, Steph. I appreciate the kind words, appreciate the intro. This is awesome. I'm really happy to be here. Yeah, like Steph said, we're going to be touching on all sorts of things from sound design to implementation with a focus on mixed reality, right? So we want to make sure that we're thinking about mixed reality the whole time, but also applying these principles that would cover any sort of sound world that you're working in, whether it's film, whether it's TV, stuff like that. So, we only have 45 minutes. And when I started working with the Circuit Stream folks initially, I was kind of struggling on, where was I going to put the pin in of where we're going to land with what I want to teach everybody, right? We can go really deep on design. We can go really deep on where to start even, square zero of sound design. We can focus on Unity. We could go a whole breadth of ways, right? So throughout this workshop, we're gonna meander, right? We're gonna go really high level some places, and then we're gonna get really deep and nerdy in other places. So yeah, I'm really excited to get going, really excited to jump in here. Like Steph said, my name's Travis. I'm a tech sound designer at Microsoft. Currently working on the HoloLens team out here in Seattle. Really proud and really excited to be at a place that lets me do the design work, right? But also do some of the technical work where I can live in both spaces. And I'm really happy to share some of that information with everybody today. And, just like Steph mentioned as well, everything in here is going to be included. We're going to be designing live on stream. Afterwards, we're going to button that up into a package, and we're going to share all that content, right? Now, it's worth mentioning, we don't have too much time. So if you miss a step, check out the recording after, ask me a question in the chat. We can go over it. But we are going to be moving pretty fast. And we're making a slight assumption that you've maybe opened Unity once or twice. I'll cover things as I go as much as I can. Just post in the chat if things are like, hey, Travis, pump the brakes, or hey, I know this already, let's keep going, that kind of thing. And again, top level, this is a primer, right? It's a kickoff. My goal for today is to make everybody excited to take the learnings and expand on them in their own apps, right? We want to get people inspired to do sound design, get people thinking about cool ways to implement their sounds, stuff like that. So we can kind of think about the next 45 minutes in three big buckets, right? We're going to cover these core principles that I think about every day as a sound designer. And, whether it's a film, whether it's a mixed reality experience, there's a couple key things that I think about all the time. So we're going to cover those, and then we're going to apply them to different things. But before that, we're going to cover spatial audio. What is it? What isn't it? How do we use it? And then how do we actually do it in Unity? And the third thing here is we want to, design the sounds. We want to go into Reaper, which is the tool we're going to be using to actually create audio in this, handy dandy microphone we have here, and some things on my desk. And we're going to cover two core sound design examples that I see in I don't know, 80, 90% of HoloLens experiences, VR experiences as well. We're going to cover some user interfaces, and then we're going to cover animations, so things that move. And then to wrap it all up, I'm going to kind of rapid fire out some other things that I hated to not go over in depth, but wanted to address because they're hugely important and extremely valuable to learn as well. So without further ado, let's kind of jump in. Half step back actually, just really quick. We can think about this asset world in three ways, right? We have the background, what's the goal? How do the sounds different from each other? How do we design the assets, step two, right? And then implementing them. It's kind of this linear progression, right? And you almost think about it this way too. The background is the why. Why are we doing this sound? Why are we even doing this feature, right? The design is the what. So what is the feature we're doing? What is the sound? And the integration is the how. How are we actually going to go from the why to the what through the how? And we're going to cover all those today. So buckle up. I'm really excited. Now, I mentioned in the beginning that we have these kind of 6 principles that kind of, drive the way I think, right? These aren't rules. They're things that I think about every day in my job. And the priority here is we want to take from silence to shipping, right? We want to cover the whole palette of the process, right? So principle 1, I'd consider envelop, right? How do we place the user in a world that we've created, right? And whether that's a HoloLens experience where the holograms are sitting in our world, in the real world, or whether that's a VR experience and we are transcending someone else into a completely immersed story. That's envelop, right? Principle 2 is ground. So if I'm standing next to the hologram, have we achieved presence? Do we have this, screen door effect where it feels like it's not there with me? What are some of the things we can do to, quote, sound like they're really there, right? This is similar to envelop, but it's more kind of interpersonal, right? It's this relationship you have with the content that you're experiencing. The next one's emote. So this is pretty crucial to anything you're doing with sound, but are we exaggerating? Are we reducing? Are we heightening? Are we altering? What are we doing to the player's emotion, the user's emotion? Do we need to be doing anything? Do we need to be doing everything? Is the sound really important to change what we're seeing or mimic what we're seeing, stuff like that? Or are we changing the pace? Are we modifying the pace of the experience? Are we doing any work around driving, slowing down, stuff like that? Principle 4 is navigation, direction. I need you to look over here. Your battery is low. I have some stuff I need to tell you, and you need to hear it, right? And I'm going to tell you that information through sound. Principle 5, principle 6, can everyone share this experience, right? Include. Are we being inclusive of everybody from all walks of life? Can anybody use this? Is everybody getting something out of this feature? Is everybody understanding the sound? And if maybe they have limitations that stop them from hearing it as I intended, how can I adjust for that interpretation, right? How can I change the sound so that we're inclusive of everybody to help use their experiences, right? And principle 6 is what I'm kind of struggling for a word with this one, but I would consider it bridge, right? We need to bridge the information gap. We have these crazy devices, right? So here I have an Oculus Quest and a HoloLens 2, and no matter which way you cut the cake, they're pretty gnarly looking, right? They're pretty awesome pieces of technology, but I'm the first to tell you VR is still really weird, right? VR is crazy. So sound plays a crucial role in making things feel less weird. How do we bridge these feelings? How do we make things, feel okay, right? I've had it a million times where I'm giving a demo to somebody and the person puts on their headset and you could tell they're getting hot under the headset because there's 6 people kind of staring at them, right, waiting to see what happens. I believe that sound plays a crucial role in always being aware of that and designing for that, right? Designing with that in mind. So just to wrap up, right? These are the 6 principles I would, kind of always suggest thinking about to some extent as you think about the challenge of the feature or the feature you're designing for, right? Envelop, ground, emote, navigate, include, and bridge, right? These cover a huge variety of things in sound design for mixed reality. It's just a quote from Hans Zimmer. I think, one of the big takeaways I'd love for everybody to have at the end of this is it's very easy for us to go on to freesound.com or, pull stuff off of YouTube and drop them into our experience. But what I want to really teach you today is to just do it, a little bit more effort, spend 20 minutes to a half hour. Not saying sound design is easy and it should always take 20 minutes to a half hour, but with a little bit more effort, we can have extremely better experiences, right? So that's just worth mentioning. Now, before we dive into the design, right, the actual making sounds, let's do a quick overview of spatial audio with a little bit more technicalities explained. There's a lot of resources on this online, so I don't want to spend too much time, but I want to give us a good primer going into the workshop. Now, before we think about spatial sound, right, what does that mean? We really want to get a good understanding of what we've had first. So I'm going to play this stereo clip. So stereo meaning I have 2 speakers, right? And I have an image between those 2 speakers. The recording in this and that you're going to hear is me literally saying we, like we, and the audio is going to move across that stereo image left to right. Okay. We. So I'll play that one more time. We. So that's only possible because we have 2 speakers, right? If we were to remove one of those speakers from the equation and put it right up the middle of the room and take the same exact audio file, this is what we would hear. So this is the mono result of that. Whee! And I'll play it one more time. Whee! So as we go from mono to stereo, right, we double the amount of channels. And we create this stereo image. Another good example of stereo imaging is when if you put your headphones on or even have speakers and you sit back and you listen to music, and you close your eyes, you're going to hear the kick drum kind of kind of dead center. It's with dance music and a lot of kick drum centric music, that kick drum is almost kicking you in the forehead, right? And then you might have the vocals kind of sitting a little further back. You might have some of the drums off center a little bit, some of the guitars on both sides. That's a stereo image, right? And we get that from two speakers, from stereo. Now, as we bump that up to more speakers, right, we can create that whole stereo image around us, right? So we can think of surround sound here as a great example of that. In this picture, we have a LCR, a left, center, right system. So the center speakers are going to be playing dialogue. The front two speakers are going to be creating some sort of image, and the rear speakers will be creating an image. But the tricky part is that they're all speaker dependent, right? We need to have speakers in physical places to do physical reproduction of sound. I love and hate this infographic because it says so much. If you, just like you all have now, gotten a 5-minute understanding of, or a primer, I should say, on a little bit of the speaker side of things. But if you're just kind of looking at this doesn't really tell you much. It kind of says, oh, sounds from everywhere, but I don't really love it. But anyway, you can really understand after explaining that from surround sound on these physical speaker locations, we can then jack that up even higher to create spatial sound, create sound that can come from any location, regardless of the number of speakers, regardless from where we are in the space. Now, we're going to glaze over this pretty quickly, but one of the big ways this happens is what's called an HRTF. This stands for head-related transfer function. And what we do is we essentially, our brains are, we're really good at parsing information, right? Our brains take in all sorts of stuff all the time, right? If you're sitting in a chair, you're hearing, the audio go by in your air conditioning, or if a bird goes by your window, you hear that bird, stuff like that. But we can kind of parse that down into two big buckets, right? We have what we call intraoral time difference and intraoral level difference. So in the example of, me saying we as it goes in front of my head, if that we is coming from the left and going to the right, my left ear gets the signal first. It comes through my head, and then my right ear gets that signal. So what my brain does, it says, okay, brain, left ear got the signal first, and then a very short amount of time later, my right ear got that signal. So it must be coming from my left. Some other things happen as well. I have a particularly gigantic head, so my head actually blocks some of that frequency content, some parts of the sound in a very specific way to my brain and to my head and to my shoulders and to my ear shapes. And that information helps my brain say, oh, okay, it's Travis's brain and it's coming from the left. We can also describe that as intraoral level distance. So my brain is essentially giving me a volume difference between the left and right signals, right? And by the way, I'm not checking my phone. I'm actually using this as a slide template. Sorry about that. Yeah, so how do we actually calculate the HRTF here? This is pretty important, right? So the trick here is we essentially say, okay, if my brain is over on the left here, if my speaker is on the left, I can play a sound out of that speaker, right? And I get a really good amount of information out of that speaker at that given location, right? I would take the recording there, I move it 30 degrees, I do it again. I move it 30 degrees, I do it again. In this image, you can see there's a whole array of essentially, microphones that we can capture, right? And after we do a bunch of recordings, we have a bunch of HRTFs, we can essentially reproduce what sounds sound like at those given locations. So let's hear that really quick.
Oh, hello there. How are you? Yes. You are here for the virtual haircut? Yes, okay. I will go get Luigi. He will come and cut your hair. I am Manuel. Just stay right there. Luigi. 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 It's Manuel. The person is here for your virtual haircut. You better come up. Right, Manuel. I come right now. He is coming up right now, and meanwhile, I will go over here and play the music, play the guitar, because that is what I do at the barber shop. It's so nice to see you.
So yeah, that's the gist of, some great little HRTF work. I did get a ping from a buddy of mine. I'm going to mute the Chrome tab for us. So we shouldn't hear that notification sound anymore.
Yeah. Hey, Travis, can you hear me here?
I think we're good. I'll bring this back up again in a little bit when we need to actually play audio through Chrome. But bear with me as we continue, folks. Thank you. So just to wrap that up, right? If we wanted to, in a traditional sense, play a bird sound from coming above us, we would take into consideration the player orientation, and we'd pan our, send some pan information, right? Say it's to the left and it's, 30 degrees, right? We determine the distance and say, hey, the bird is 30 feet from me. Maybe it's 50 feet from me. And we calculate a volume based on that distance. And then chirp, chirp, the pan and the distance play the sound. But with spatial audio, we have a little bit of an advantage here. We can actually say, okay, we know the bird is 30 degrees to my right, and we know the bird is 50 degrees or 30 degrees above me. We go to our set of HRTFs, which are, recordings of what sounds would sound like at those locations. And we play that, right? We play that sound. And as you've heard from the last experience and the video that Steph played for us, it almost makes you turn your head, right? It gives you that extra bit of immersion that sound is really coming from over there, right? It's really powerful stuff. But how does this actually help our experience, right? Well, spatial audio, as Steph said, it's an immersion multiplier, right? We have tons of signal across all devices that people will stay in your device longer, right? That's awesome. The biggest one, though, in my opinion, is that it really helps us parse information, right? We can, as we think about the information our brains are taking in, we parse out a lot of stuff. We kind of filter out what's not important. And the good example is if someone's behind my wall right now, obviously they're quieter, but there's some occlusion, there's some blocking of the sound because there's a wall between us. Even though they're quieter, my brain is filtering that because of what we're hearing, right? It's saying, oh, it's not as important, Travis, it's behind the wall. It really helps us parse information. We saw that a lot in AltSpace VR a couple years ago when we started adding in occlusion features. People started having more complicated conversation scenarios, 5 people, 6 people, because they were able to group up into smaller circles and not hear all the craziness of what was happening around them. And then, of course, accessibility. Some folks really rely on hearing to use all of your XR experiences. And the more information we can pump into the experience through audio, the better the better time they're going to have using this, right? It's going to be a much better experience for them. Not to mention navigation. With all this HRTF calculation, we are clearly telling you where things are happening. So why not take advantage of that and tell you where things are going, right? And then grounding, back to one of those principles. It will help you tell the story and help you be there with the hologram or with the virtual object, whichever kind of VR experience you're doing. Now we're going to kind of jump over this a bit in detail in one example, but Unity by itself doesn't offer an insane amount of spatial audio features, right? We want to pull in third-party tools to really nail this home. So some of those tools include the Microsoft Spatializer, Microsoft Acoustics, Oculus Spatializer, Valve Steam Audio, Resonance Audio. Each of these kind of has their own HRTF, right? Their own set of ear recipes to make that happen. And then things like I mentioned, occlusion, directionality, and then middleware support. This is for another talk, though. We can totally go over all these different spatializers in detail. Now, we'll go into Unity in a bit, but just so we have a good understanding, there's a couple of big things we want to mention here. Spatialize checkbox in an audio source. So I'll just zoom in on the slide here so you can see it. So spatialize, right? Sounds won't spatialize if that's not checked on. Attenuation, so how sounds actually roll off and how they change over distance, that's crucial. And then we have this feature in Unity called spread. We'll go into this a bit later, but spread is essentially how much of that signal are we spreading into 2 ears. So for example, if I have a sound on my right and I have spread set to 0% of that signal will be hitting the opposite side. And as we increase spread, we'll have some more of that sound come over. It's a good way to do things like perceptual size. So if a T-Rex is in front of you yelling versus like a mouse, you can adjust spread to make that sound be a bit wider. That's up to design intent, though. We'll kind of go over to that a little bit later. And just a hot tip, it's a great idea to kind of set up, once you have your device working and you have everything kind of running in an experience, set up different audio source prefabs so that we can we can just get those attenuations off the fly instead of trying to set them up every time. So I guess, to wrap up spatial audio in 10 minutes, you've heard the difference, so use it. Spatial audio it's affordable on every platform you're going to use, whether it's Oculus Quest, Oculus Rift, Vive, HoloLens 2, any at this point in 2020, it'll work. You have, of course, CPU things to consider and, your budget, but this isn't something like it was that was very extremely performance intensive and couldn't be done, right? We can do this today with any sort of platform you're using. And with those, with those different spatializers, some things to consider are the engine, right? What platform are you shipping for? Are you shipping on Nintendo Switch? Are you shipping on HoloLens and a PC? All these different platforms, right? You want to be considerate of that because sometimes certain platforms may not work best for others. And then, of course, your CPU budget. Some of these platforms are more expensive than others, so that's something to be keeping in mind as well. All right, so now that we got the, the lecture part of the workshop out of the way, let's actually go in and design some sounds. So the first big bucket I wanted to go over was user interfaces, right? So when we think about user interfaces and back to those core principles, we really do touch on, maybe I wouldn't say all of them, but almost most of them, right? And just to call out the slide here, in a world of constantly changing hardware and foreign input systems, UI audio plays a crucial role in helping users like feel comfortable and understand what they're doing, right? 3 years ago, you weren't using your eyeballs to like select a thing, right? And now you can do that on a bunch of devices. 5 years ago, you were not using your hands in VR. You were using Vive sticks that you had to set up cameras in your house, right? So the input's changing a lot, and sound can be a really good way to kind of ground that experience. And just to dive into a bit more, some of these buckets that we really want to think about are relaying information. Are you gazing? Are you confirming? Are you going back? Are you going next, right? We can create sonic unification. You really wouldn't smash together the visual language of like Halo 2 and Pikmin, for example, right? That would just be weird and it wouldn't be cohesive unless the entire game was, Master Chief meets Pikmin, right? But it's, UI is a great way to gel everything together. And then we can outline the experience for every user, right? Always going back to accessibility, making sure that everybody can use their devices and everybody can use their experience and get what they want to get out of that device, right? So I'm just going to crank up the Chrome volume one more time so we can hear what I'm playing. So I want you all to think about what you actually hear when you're navigating the UI in a Nintendo Switch. I love that whole experience. I think they did an amazing job kind of telling a story through just, some relatively simple bleeps and bloops, right? And just to call out some of the things in there, right? It sounds like Nintendo. You can almost close your eyes and if I played those sounds, you had to guess, hey, is this a PlayStation UI, a Nintendo UI? What would you pick? You'd probably pick Nintendo because it almost makes you want to smile, right? Another call out there is that the very repetitive sounds are pretty simple, right? So as you're scrolling, it's a very simple click. But if you're moving menus, if you're changing, between bigger buckets of the experience, you get a very specific sound, almost, something that is, very characteristic of the event that you're doing. And then one more call that I really enjoy in that experience is that when you go back, you have this very musical tonality of going home, right? Things are resolving. The key that the music and that UI is written in, that root note, that kind of home place is what you hear when you go back home, right? It all kind of gels together. And the biggest one here is that we are creating this kind of UX family, right? Scrolling a menu versus scrolling a friends list. They're similar actions, but they sound just a little bit different, right? Entering a game, leaving a game. All these sounds were designed with intent to create a story, right? And back to where, our accessibility comment, if you had your eyes closed and you were navigating, you'd be able to get through a lot of, if not every single part of that experience, right? That's not easy to do from a design standpoint. And it's really great to see that they put a focus on that. I'm sure you're saying, hey, Travis, like this is really cool and all, but what about mixed reality? Well, these concepts apply to any sort of sound design, sure, but we have a couple things in mixed reality that are really important to address here. As we said, we have really unconventional input models. So for example, I'm used to using my cell phone, right? So my phone can scroll with my thumb and I could, everybody in 2020 is really familiar with what UX on a phone is like. But then I hand you a mixed reality device and I say, oh yeah, log in by looking at that sphere. And once it's done spinning, it'll open. It doesn't make any sense, right? We have this very unconventional input model, and we need to relay those stories in the most cohesive, familiar, and comforting way possible. Not to mention as well, using the Nintendo Switch example versus mixed reality, we are now popped off a screen. So panels and UI information can sit right in front of my face. It could sit over here. I might be telling you to go somewhere else using a waypoint and playing a sound over there, right? This more access of control makes it a lot harder because now we need to prioritize and help prioritize what information are we trying to tell you at any given frame, any given instance of the game, right? And then, just to wrap that up, we are combating with clutter. Let's say, you're in your VR experience and there's all these animations firing. Every engineer in the game is doing something cool. You're doing something cool. There's some voiceover playing. How do we fight that to make you have the most cohesive experience and relay what you need to hear at that given moment? Maybe some sounds aren't as important as others. Maybe they are. So let's actually hop in now and design some sounds. So I was struggling with this at first because I was like, hey, how are we going to, we need to come up with some sort of story. Here I am pitching all these design principles, right? How are we going to actually start with this? So what I wanted to start off first was with let's think about how I would go regardless of the project. So I have this attached template asset sheet that we'll include in the chat, but we're going to basically list the sounds and go from there, right? We're going to list the sounds and list the status of those sounds. And then we want to think about cohesion, right? What world are we creating? No matter what, we want it to all feel the same, right? Regardless of the story. And then one more call out is that, hey, heads up, once you have UI audio, things that don't, they're going to feel broken because you might go press one button and it might go bloop, and then you might press the other button and you won't hear anything. The user's going to think that's broken. So as soon as you enter this world, you're in it and you got to finish the story. So the story I wanted to tell here was this made up experience called Sharkland XR, right? So let's say, I walk down the street to the Seattle Aquarium and Shark Month is making an app to teach people about sharks and how awesome they are. The design pitch to us was that it's for all ages. The design is really fun. It's super stylized. It's not realistic. The folks are going to throw in a HoloLens 2 at the shark tank, and they're going to be able to look around and see some information about sharks, right? Bear with me. I'm not a game designer. I'm not a product designer. I'm a sound designer. I work with my ears. So the game might not sound awesome. Bear with me. And one more call out is let's assume that folks have never used mixed reality before. And let's assume that it's a loud environment, right? They're in a museum or an aquarium on a Saturday. So some of these features are, maybe we want to open and close a menu to learn more about the different sharks. Maybe users might rip the headset off because they're getting called to walk down the hallway or their 5-year-old went running away. So we need to be able to detect, hey, are you still there or are you not? And how do we relay that information, right? So if we tie that back to these design principles, we have a couple that pop out to me, right? So we have envelop. We're actually not concerned with envelop here, right? This is a very passive experience. It's something, a HoloLens may be sitting on the wall. You may or may not even pick it up, put it on your head. We're not trying to create this entirely immersive experience, right? We want to just relay some information when you need it. With that though, we need to consider emote, right? Let's make it fun, right? This is a fun experience. We want people to smile when they put it on, right? And for first-time users, smiling is really important. And navigate. So let's make a panel that's really obvious that we're hydrating the button that you just selected, right? New input models, people have never used VR. Let's really sell that, right? Let's make sure we have enough differentiation though, to make sure that users with these accessibility issues and needs can sense the difference between the open and the close and what they're doing. So even if they can't see it, they can have a great experience. And back to bridge, right? We can assume that this is a very weird new thing to some. So no matter how good your sound design is, we don't want to overwhelm the user. We don't want to make them uncomfortable. We don't want things to be too loud, and we want it to be a great experience for them. So from here, what I did the other night, I basically came up with this Sharkland VR idea, and I made a little video. So let me crack open the volume mixer one more time. So yeah, that's basically, me obviously with some bubbles sitting in my room late one night. I'm just gonna make this full screen for you guys. Hang on. Sorry about that. So yeah, with some bubbles, trying to get some captures of what we could potentially use for sound design source here. And obviously, I wanted to make sure I used what I had available. I didn't want to use any plugins or any sound design libraries. I wanted to make sure that we could, do this together with anybody using their tools, right? So the microphone I used, yeah, it's not the cheapest. It was, a $200 mic. You could have used an iPhone. You could have used anything. The quality of this mic is not that great, right? I used some glasses on my desk. So like one of these, right? And then a glass straw. I obviously didn't have the intuition to record the video in landscape mode. Sorry about that. But the point is you don't need fancy tools. The only call out I'd make here is that I did use this tool called Isotope RX to remove some unwanted noise. Now let's actually jump over to Reaper really quick. So this is Reaper, right? This is the audio design tool. And I will just really quick, if folks can't hear me, if you can't hear these sounds, let me know. So those are our bubble recordings, right? That's the exact recording that you heard in the video. And the first thing we wanted to do here was basically, let's do an open menu and a closed menu, right? Let's try to tell that story really quick. What I did was I kind of went through here and I said, okay, I liked a couple of these little bubbles. So I'm going to solo this one bubble, this first one here. I said, okay, that could be used as a little notification of some sort. I then took another bubble. I added a little bit of an effect to it. So I took this bubble, I actually added what we call a delay. So this little delay you'll see here is it's called a Reaper delay. So it's super simple. Going to play the sound twice. You can think about it almost like a quick echo. And just to give kind of a top level really quick, Reaper is just like any other DAW, right? It's any other tool that anybody could be using to record audio. Pro Tools, Reaper, Nuendo, even Audacity can get away with a lot of things we're doing here. I wanted to keep it super simple so that anybody can pull these sounds in and do exactly what we're doing here. And then the third sound I pulled from my recording was this other bubble, right? This one's kind of a little high-pitched little accent, right? It's a little anchor point to say on the sound, right? And when we glue those all together, we do a little bit of pitch manipulation. We change the pitch for certain sounds. We adjust the timing. We adjust the length. When we play those all back, we get this. So just this first one, right? Pretty simple, but it's totally going to work for what we need to do. And as we look over here, I took those same sounds. I changed the pitch here so that they had this kind of closing feeling. The pitch goes down, right? A lower pitch, meaning like lower frequencies. So if I just kind of solo these two tracks, I'm going to play the first opening bubble, original, right? And then the second one is going to be a reversed, played backwards instance of that sound and pitch down. Super simple, right? We're really thinking about sound design 101 here. Keeping those things in mind, you get these two sounds that one is kind of opening the menu, one is closing the menu. All I'm going to do is take this sound, open my export window, and I'm going to call it Shark, or I'm going to call it UI. Shark menu open. And I'm going to keep it in mono for now. Take our second sound here, Shark menu close. Let's rename this to close. Okay, great. And now just to make sure we're all good here. Sounds good to me. Cool. Cool. So now, folks, I'm just going to jump back to the presentation really quick, just to pull up our slides. Yeah, just to reiterate, we dropped the pitch down a bit, we added some delay, and on high bubble, we did no processing here, right? Just a little bit more context. Same with the close, right? Oh, I need to fix my formatting there. Apologies. Same with the close, right? This classic pitch manipulation, we wanted to switch those to make it opening and closing. Before we jump into implementation, I'm going to go over to Unity really quick. And what I did here was, and just to kind of breeze over it, I brought in the Mixed Reality Toolkit. There'll be a link in the description on how we actually pulled out the MRTK. MRTK is Mixed Reality Toolkit to implement these sounds. And we're doing a super simple solution here. So here's two buttons I created. Just going to be Shark menu open, Shark menu close. I'm going to jump over. Let me magnify this so y'all can see. So over here, just in my scene, MRTK is essentially button examples solution, super out of the box. I'm going to go to my open button right here. And I'm going to look at this pressable button component. So right here, I have the function call ability to basically say, okay, what am I doing? I'm working with open button. I'm going to go to audio source. I'm going to go down to play one shot. And here we go. Our sounds are here. And then I'm going to go to close button. Going to do the same thing. Do audio source, play one shot, menu close, save that, and let's hop in and check it out. Hey folks, are you able to, I'm not sure if you're able to hear that. I hear it here, but I'm not seeing my meters bump up. Hang on one sec. Really quick, just so we get to the same point in the slides. You know, MRTK gives us a great starting point. Don't worry if you're not using it, right? We can kind of blow through that. You know, as we look at the audio source allocation, we're just going to do one button for one source here and get those sounds rolling. Now we want to think though, are we going to play this on touch, on release, on scroll? Where does the sound come from? All sorts of things like that, right? So let's jump back over to our button here. Great, so we're working in Unity here, and this all sounds good to me. What I want to do first, though, before we actually get this all running, I'm kind of realizing that, you know, with this sound, the way it's set up now, I don't think it gives us enough, right? We're going to have one button sound for one press and one button sound for another press. I want to actually take this a little bit further. So I'm going to pull in this script I wrote here. Let's see. Cool. So what we're going to do is write this script called audio pitch control. I can't remember the name. Sorry about that. And audio pitch control is going to let us randomize that sound's pitch before we play it. Now, really quick, all we're doing here, again, you know, super quick and easy, sound design 101 implementation. We're calling in some variables, and then we're going to make, you know, public void change pitch. I am reading my notes. Apologies, just so I make sure I make this right for you guys. Change pitch. We're going to open up this and basically say, hey, you know, if random pitch, if randomized pitch, we're going to call that source, right? Source.pitch. And we're going to set this to a random range between our pitch minimum. I'll explain this in a second. And pitch, pitch min and pitch max. I'm checking my time, folks, so I'm going to try to blow through this for us. Cool. And then one other thing we want to do is declare another function called pitch toggle. And pitch toggle is going to basically allow us to do a quick little randomized pitch. It's going to let us do a quick little check to make sure that we're actually doing this when we check on and off a checkbox, just as almost like as a debug. Randomized pitch equals, I'll explain this in a second. Oops, sorry. All this is really doing is saying like, hey, you know, set a Boolean, and if randomized pitch is a thing, set pitch back to what we were, right? Set it back to set the source pitch again. So let's go like this, and then we're going to open up again. Source.pitch equals 1.f. Cool. I am trying to blow through this just for the instance of time, so I apologize for that. Why don't you like my randomized pitch? Oops. Nice. Okay, cool. So what we're going to do now is jump back over to MRTK. Cool. So as you see, audio pitch control here, we have the ability now to say, what is the pitch minimum? What's the maximum? And that's basically saying, okay, Unity's pitch slider, we're going to pick a range in here. And every time we look at that range, we're going to play a different pitch based off of that. Drag in my source. Going to make sure this is working, right? Save my scene. Going to go back to open button. I don't know if I actually like touch end as a point, as a playback here. Just to make sure though, let's make sure our spatialized checkbox is on. Sounds are set to 3D. Stuff like that, right? Cool. Cool. That's okay, our errors are fine. Oh no, hang on, bear with me. All right. So yeah, as you can hear, you know, we're randomizing that pitch as we play it, right? As we go back and forth. We don't hear anything on the way in. We had it set to press release, so we hear that sound. And that's kind of a, 101, right? 0001 plus a little bit of extra script to kind of make that do its thing. All right, we went over this. Yeah, we're going to kind of jump over the audio mixer for now, just for the instance of time. And just some takeaways here is that UI is this great accessibility tool, right? We can tell a lot of information from UI alone. We're telling this story where it's really great for relaying info. We can help the player, look where and when you need them to. Now, really quick, let's just jump into another kind of example here, animations. So let's go back to the principles, right? How do we actually use animation to line up with what we actually need to design for? Envelop, where does this take place? Ground, what can we do with the holograms, with the virtual objects? How do we actually match the animation's emotion, right? What can we say about the animation for someone who can't see it? And we don't want to scare people again, so let's keep the volumes nice and tidy. Now, all we're going to do, just jumping back to Unity really quick, I have a quick little animation that I pulled in here. So I'm going to play this for us. Okay, sorry, folks, hang on. Like this really quick. I'm going to actually turn these buttons off. I think they're making Unity very mad. Go, nice, that's better. As you can see, this quick little animation, we have this awesome character just standing there, snapping their fingers. Now, implementation 101 for this, we're going to go into the prefab. This is the script we're going to modify in a second, but we're going to go into the prefab, pull open the animator, jump into the animation. And if you look down, now I'm on the bottom right of my window here. I have this opportunity to drop in events, right? So I'm going to make a new event. Well, actually, first, let's look at this window first. Let's look at the actual animation. So I have the animation here, and as I play it, we can see where that snap happens. So what we want to do is, do stuff when this animation fires. And all this is going to be as a function on a keyframe to say play a sound. These are great for footsteps, shooting weapons, stuff like that. So jumping over again to Visual Studio, this is, again, a really quick script we have here. We're pulling in the audio source. We're pulling in the clip we're going to play, and we're just going to go void start. Start. We're going to, pull in the source. Source equals get component audio source. Cool. And then all we're going to do is make an event that the animator can, or I'm sorry, make a function that the animation can see. Void on audio event. Let's call it on audio event like that. How's that? So now what we can do is actually play this function when we want to do stuff in on the animation itself, right? And all we're going to do is source.play one shot, right? And then the clip we want to play is clip to play. Cool. Save that, right? Jump back over to Unity. All we're going to do is try to get this pretty close. We're going to try to say, okay, how is that? That's close enough. So this is the frame we want to do this event on, right? Open up our events. And what do we call our function here? On audio event, right? So we're going to call on audio event to our animation audio script. Save that. I'm going to go back over to the character here. I'm actually going to drop in the source, right? We don't have the source yet. Set this to 3D. I just realized we didn't even record a clip here. So let's go over to Reaper, drop in a new track. Now I'm just going to record myself snapping. Okay, so I'm going to press record. Cool. It's quick and dirty, right? Don't love it, but it's good enough. Export this sound. So UI, let's call it character snap. Oops, I want to just do my time selection. Sorry about that. Yes, alrighty. Character snap, jump back over to Unity. Put this in the top folder here for class audio. All I'm going to do, go over here, drop in our sound, clip to play, drag in our source, and let's run the scene. Easy. So for the instance of time, I would have loved to take this and set up an array of snaps, right? Set up 5 or 6 array sound or snap sounds, and then randomly change the rate and the timing of those sounds. But unfortunately, we're pretty tight on time, so I'm just going to keep going. So just to kind of wrap up and touch on a couple more things, we do need to get on acoustics, right? Acoustics are critical for immersing your player into the world, right? Dressing up your spatial audio. In the example of the snap, we need to put them in a concert hall if they're in a concert hall, a pyramid if they're in a pyramid, right? A bathroom if they're in a bathroom. Microsoft Acoustics, Google Resonance, great things to consider for doing that. And just to kind of visualize, right? What would this hologram sound like if they were actually in this kitchen or this living room or this weird office? I don't know. I see a counter back there. Wherever they are, right? What would it sound like if they were there with us, right? Going back to ground. Voices, right? We didn't even talk about VO or narration. Always consider the impression that voice is going to have on the user, especially the positioning. If there's no hologram there or no object there, it might not be best to just randomly spatialize the sound because Travis, the sound designer, told you to spatialize the sound. It might not be best. So always think about your experience, go back to those principles, and if you drill down those, you should come up with a solution that is going to at least cover all the bases of making sure the user's happy in there. Music, right? We can totally spend hours talking about music in mixed reality. Unfortunately, not as much in a primer, right? Music checks off, if not just as much more of like my sound design parameters, right? So it's going to cover everything. What are we trying to say? Are we trying to drive some emotion? Are we trying to pull back the emotion, drive the story, stuff like that? And, really, I would have loved to cover this more, but ambisonics is, a pretty strong alternative to stereo music here. And again, we can go over that in another talk, what that is and how to use it. So yeah, some of my recommended tools just to kind of wrap up, Reaper, some, portable recording devices, the Sony M10, some LAM micro microphones. This Node NTG3 is pretty good. Some halfway decent headphones. And then some of the plugins that I would recommend, even though I wouldn't recommend diving into plugins right away, are Isotope RX to clean up your recordings, FabFilter Suite, which is a great plugin set to do pretty standard sound design tools, and a Reverb plugin, to get your head around space and how to design spaces. And then if you are really focused just on mixed reality, Deer VR is a great option for this as well. And so some of the things we'll went over, we'll share this resource later, but here's some of the tools we use, some of the tools we talked about. Some more resources that I definitely have to give a shout out to learn and to help folks with. Marshall, Akash, Reaper Blog, Andrew, all these folks, they do an amazing job of teaching folks about sound design. So a lot of the stuff we're sharing, they do share as well. Highly recommended to check those out. And then these are some blogs I definitely recommend checking out as well. The Manning book about Unity and C# is a great one, right? So that's an awesome resource for you as well. And some conferences, Game SoundCon, GDC Vault, AAS AVAR, SVVR, VRLA, awesome communities for learning about spatial audio. And of course, can't go without mentioning the Wise Spatial Audio workshops that they've been hosting, and walkthroughs have been super killer as well. So yeah, thank you so much, folks. I know it's a bit of a whirlwind trying to get through all that stuff at once, but I really do appreciate everybody coming in and learning with me. It's been a blast. I've had a lot of fun. I think I'd love to come back and share more of the code side, more of the design side, but hopefully this was a great place, a great starting point for you to kind of learn a bit about spatial audio, learn a bit about how to design, how I approach my design, and then also do a little bit of implementation. So thank you so much for coming by. Really do appreciate it.
Right on. Well, hey, thanks so much, Travis. Really do appreciate it. I know we had to fly through this quite quickly on our end, but we will have Travis join us again to do a more in-depth sound design workshop and webinar. I will toss in a poll here just to see, on a scale of 0 to 10, how likely are you to recommend this workshop to others? Just so we can continue creating these workshops, invite Travis again. We will have Travis join us here shortly in the next 5 minutes or so for the Q&A session. But again, thank you, Travis. It was truly an honor and a pleasure to have you. I'm glad we were able to figure out the chat notifications there. But I will take about 3 minutes just to quickly wrap up this presentation, and then we will have Travis join us again and answer some of the questions here. I know the questions tab is pretty full, so very happy to get those rolling. But essentially, I know we flew through this content very quickly. And for those of you who are advanced, looking to take a step further, we do have an XR Project Accelerator course really to polish up your projects. If you are an advanced XR designer or developer, feel free to check it out. We'd be more than happy to talk more to this. For the beginners out here, if you're looking to dive into this more as well, we have that XR development with Unity course. It is beginner friendly, all live and online in real time, 4 hours a week over 10 weeks. And our next course starts on September 28th. So what can you expect to learn in the XR development with Unity course? Essentially making VR, AR apps and projects in Unity. We'll also show you the fundamentals of C# coding. Again, it's 10 weeks long, 4 hours a week, 3 in class, and 1 hour private weekly one-on-one session with our designers and developers. It's project-based, so you come in with an idea that you want to create and develop, and we support that development alongside you over 10 weeks. Now, we do offer payment plans and financing options as well, from 3-month plans, 6-month plans, and 12-month plans. Again, if you're interested, feel free to reach out. More than happy to talk and speak to it a little bit more. It's no experience required, so newbies, have no fear. We welcome everyone from all walks of life and are super excited to help you all learn. So if you're interested, download the syllabus or apply now at circuitstream.com/course. Now, I will quickly re-invite Travis back onto the stage here to answer some of the questions that we have in the questions tab. I know there's a lot to get through, and luckily we have, we'll open it up for 15, 20 minutes, if not 30 minutes, to answer those questions. And great to see you again, Travis.
Hey, thanks, man. Yeah, thanks so much. Appreciate it. Thanks. So, Steph, do you want to drill through some of the questions? I can kind of go from the top and parse through, or whatever you think, man. Whatever you prefer.
Sorry, could you say that again?
Yeah, no worries. Would you prefer if I just kind of parse through the list here, or would you want to call some out? What do you think?
Yeah, sure. So let's see what has the most upvoted ones here. So it looks like Rich Lee had a question here. I'll toss it here live. So speaking about different variables, dimensions, etc., you talk about angle, distance, and occlusion. Is there a place that he can find all the ways you might describe sound?
Yeah, this is a really good question. I think, unfortunately, sound designers, we've, developed like different colloquialisms for how we speak about things. And that can, definitely come, poorly relayed to folks who aren't, in the design world as much. Short answer is yes, absolutely. I would definitely recommend checking out, so Google Resonance, one of those spatializers that I mentioned. Google Resonance has a pretty awesome, it's in our resources list, but it's a really awesome breakdown of occlusion, transmission, all those things. I definitely recommend as well, the Unity Unity repo. They do an awesome job too of talking about their components and all the different parameters you can have. And those parameters, yes, they compartmentalize right into angle, distance, occlusion, stuff like that. For sure.
Beauty. Let's see what else we got here. I know our man Alden Braverman had a question specific to the HoloLens. Can the HoloLens handle DSP onboard?
Oh, cool. Yeah. Wow. It feels like a softball pitch. Yeah. We do actually. So we have some really awesome tech in here that we actually can take. If you're using Microsoft's HRTF, we can actually drive off. We call it like on silicon, where you can take audio sources. I believe it's up to 30 now that you don't actually have to pay for in Unity. You get those allocated for free on the device. So if you're using HoloLens 2, there's absolutely no reason you shouldn't be using spatial audio, because up to a certain point, you are literally not paying for it at all in terms of, CPU costs, right? So definitely.
Wonderful. Let's see what else we got here. So we got Alden Braverman done. Richard had a question that I'll get back to here shortly, but Ali Taheri, are you using any audio spatializer in Unity or just the default audio effect?
Yeah, another good question. I brought in the Microsoft Spatializer this morning. I didn't actually hear it firing when I was, rolling through all the content. But considering I had the spatialize checkbox there, like it showed that I could do it, some sort of spatializer was brought in. For the workshop, I was trying out the Microsoft one, the Google one. I'm a bit on the fence, but I'm 95% sure we were using the Microsoft one in that demo. If we weren't, we should have been.
Right on. And I know Carrie here had a question as well. What is your recommendation to get on getting started with quality recording device, microphone to capture sounds, binaural microphone?
Yeah. Awesome. So This is the Sony M10. Sony doesn't actually make these anymore. You see them pop up on Craigslist all the time. I absolutely love this recorder. It's so just for perspective, here's my Pixel 4 XL and here's my Sony recorder. I take it everywhere with me. It sounds great. I can plug in microphones into it. Like I said, they go used. I think you can get them for like $200 used. They're awesome. So highly recommend those. If not, the Zoom stuff is great. Zoom H2, I think is their cheapest one now. I don't really remember, to be honest. The Zoom stuff is great. Definitely recommend picking up the Zoom. I don't think you need to worry about too much about binaural specific sets of microphones just yet. Something like this Rode NTG2 is great for capturing like mono sources. If you did want to go into stereo, if you wanted to work on like, stereo capture, the microphones I definitely recommend are these. So these are called, it's from this guy out somewhere in Europe called LOM. The place in Europe is not LOM. His company's named LOM. And as you can see, these are two super teeny tiny microphone capsules. So they're really small. And these sound great for binaural ambiances like you called out and for recording things outside in stereo.
Awesome. Now, were there any questions that you had saw that maybe piqued your interest, or do you want me to keep tossing some your way here?
Yeah. I can kind of just go through here. Main differences between the spatial audio applications. Well, the short answer is they all use their own HRTF set, right? Everyone essentially has their own ear recipes. So some of those are recorded in a lab with a dummy head. Some of them are sampled to over 1,000 people, right? Everybody has their own way of capturing those. So that's one. So that means it might sound better to you than to someone else, right? That's like a general HRTF. And each company has their own general HRTF that they use. Also different features. So some of them come native with acoustic support. Some of them you have to include other support. Oculus, they do some really slick stuff, native integration with the hardware, obviously, because they make the Quest and stuff. I did have a resource that we will share out that there's a blog. The name is slipping me. They do an awesome breakdown of all these spatializers, but those are just some of the things that come to mind. Do I ever record in ambisonic formats? Yeah, I do. So I have this mic called a Sennheiser Ambio that records ambisonics, good for like sound field captures. It sounds great. It does a great job. If I feel bad talking about ambisonics, we didn't really cover it, but yes, I do. We use those for a lot of things. What did I just saw one go away? Oh, have I used DaVinci Resolve as a DAW? I haven't. I'm a huge proponent of Reaper. I think it's really cheap. It's like less than $50, I think. Unless you're at a big company, it's like 200. Compared to like Nuendo, which is thousands, and Pro Tools, which is like some insane amount of money now. So I haven't. Happy to try it though. Richard, to clarify, would you have to insert sounds dry into Unity and apply reverb through a plugin in Unity rather? Yeah. Okay. Good question. So for mixed reality, yeah, I would definitely recommend. And just to be clear, when we say reverb, I'm meaning the presence of space, right? It's always, not always, but a good practice I'd recommend is as you're gluing sounds in the same world together, applying some sort of small reverb to make them kind of gel into one sound. So for example, for the bubble we use, we probably should have put a very, very small reverb on the bubble, on the different bubble clips to kind of group it into one sound. But yes, in terms of putting that sound in a space, we don't want to put the space together in a DAW and then bring it out into Unity and then apply another space to that. I'm sure there's one-off examples where you might need to do that in the DAW. If you're like, let's say you're totally performance strapped and you want to play like a stereo sound in Unity that has a ton of reverb on it because you can't afford reverb on your experience for Gear VR or whatever reason, then yeah, but I would definitely say a good rule of thumb is to keep it pretty dry going into the engine. Let's see. Dale Campbell, I have a Zoom F8N, now looking for a pro mic to work with. Yeah, cool, man. I would definitely say get on the waiting list for all the LOM stuff. For the price, you can't beat it. It's just so awesome. The guy, I haven't spoken to him before, but the pre-orders go up and they sell out in minutes because they're awesome and super cheap. Do you need to design/code Unity from Mark here? Do you need to design/code Unity for different sound output devices? Example, headset versus 7.1 system, or is that what spatial setting is for? Yeah, good question. There's kind of like no umbrella statement, but basically, if you're using virtual reality devices, all of the upmixing to different channels, whether it's 7.1, like if you have an actual sound 7.1 system, or if you're actually outputting to the headphones, or you're outputting to your Rift or whatever, that will happen with the spatializer, right? The spatializer will do that for you. So yeah, in short, yeah, that's what the spatializer is for.
There's a question here, Susan St. John. How do you think XR could be used in music education?
Yeah, I wish I had like a 2-minute answer for you, but there's like endless opportunities, right? I have a lot of friends pursuing the space both from the music education side and the education side, and the possibilities are endless. I think when we think about setting space, right? The creation of perspective and whatnot. I mean, I can't think of a better way to conduct in front of an audience and understand the different pieces of an orchestra than actually hearing them coming from that side. Hearing the trumpets from the trumpet section or from the brass section, right? Orchestration alone is like, yeah, go make that happen, make a bunch of money, right? As for, teaching people about music, I mean, it's a great experience, right? Listening to music with a bunch of people in a virtual environment is a lot of fun. I think it provides a great place to communicate and discuss and share, right? I think, we do have a bit of time before. Let me take this question in a long way, actually. When I look back at like the Beatles, when the Beatles were, one of the first bands to really start using stereo as like a creative thing, go listen to like some old Beatles records and the drums are like off on the right. Right. And it's like, sounds super stupid in retrospect. It's like kind of just, it's like jarring. If you listen to some really nice new record, you're like, wow, why are the drums over here? And it's because they were experimenting, right? They were messing around with this new format and messing around with new things. We're in a pretty similar situation now where, artists are trying to mess around with, VR experiences and having like the vocals fly over your head. And like, yeah, it sounds cool, but it may not be the most effective for like in an education standpoint of like relaying information and trying to like make the user understand what you're doing. So I think to kind of wrap that thought up, I think I see a lot of folks doing all these crazy things when I personally don't believe that we need to do that if education is kind of the goal, right? I kind of lean into more like if it's not broke, don't fix it scenario there.
All righty. What else do we got here?
Let's see. Oh, do you know any audio spatializers that you can use in a DAW for spatial audio music production? Yeah, totally. So that Dear VR tool I mentioned, they do an awesome job. Facebook and Oculus, right? They have awesome plugins that work in DAW, so you can actually use your Oculus Rift in Pro Tools or in Reaper and spatialize things with the touch controllers and hear what they would sound like before you bring them into Unity. If we were to do another workshop, that's something I would definitely experiment with, because the gap there is, we're designing sounds in Reaper and then putting them into Unity. By the time we get on device, we designed that sound 20 minutes ago, right? Where a better solution would be, actually putting a headset on in Reaper and hearing it. So absolutely, totally different solutions there for sure. Touch that. We got that one. And what do you think of use of this webpage? Tree.js. Don't know about that one, so I'm going to skip that one. Once it has .js, I'm pretty useless. Let's see. Yeah, so the audio source stuff we were touching on there, yes, that was a standard built-in Unity component. A lot of these spatializers, they are built on top of that component for the simplicity's sake of like, you can just slap on that spatialize checkbox. And if you want more features, add in their scripts to the audio source and expand on that. But they are built on top of the Unity audio source for sure. What headphones do I use? Yeah, so these are this company Bayer Dynamic. These are the DT990 model. I love them. I think, they're open back, which means, I could hear things outside my headphones all the time. Their closed back is, you put the headphones on, you can't really hear anybody, right? They're open back, so that relates really well to things like the Quest and the HoloLens 2, because these are also, not blocking any outside sound, right? They sit, the Rift will sit on top of your ears. The Quest are like near throw speakers, right? So I use these, I've been using these for a long time, probably like 6 or 7 years now, I think. And at the end of the day, you just got to really know what your headphones sound like when you need to know what your sounds are going to sound like on all these devices. And I have a really good understanding of what my sounds are going to sound like on these. And it goes back to like, if it isn't broke, don't fix it. I've tried different headphones, and I think some headphones are more fun to listen to than others because they might have more bass and they might, be more enjoyable, more comfortable. I might look cool like on the mountain snowboarding with like these big funny headphones, but I know how these sound really well, and that's the most important thing. So if you find a decent pair of headphones that's comfortable, you like how they, you like the sound perhaps, stick with them and practice. right? Practice using them all the time, because then you can have a really good understanding of your work and how it's going to relate to other platforms. What would you advise someone, from Hubert, who only has experience making music and wants to get into sound design? What sort of portfolio do you think is required to land a game sound design job? That's a whole nother talk, man. I love it. So, as a musician, you have a really great pulse on sound. You do. You have a really great, inherent rhythm, right, on how to create content. That's super applicable. So what I would say is the tips I put out here: get a microphone, get a recorder, and look at screen captures, right? Look at your favorite game, your favorite movie, and try to recreate the sounds that you hear there. So the animation we use is a great example. That's literally someone going like this. What would you do? You'd make a snap, right? Take it a step further. Is it a weapon shooting? Is it someone running down a hallway? And just take your intuition of how to, mix drums and how to mix guitar and apply it to a more contextual standpoint, right? As for the portfolio for a game sound design job, I definitely recommend this resource called Real Talk, REELTALK. This awesome audio team, Power Up Audio. Kevin's a buddy of mine. He does basically a Twitch stream where they share. He brings on an audio professional and they go over submitted reels for people, and they have all sorts of awesome insight. They've hired people like from Real Talk, like, hey, this person was in Real Talk and then they got a job. Check out Real Talk, but the TLDR there is you have interactive sound design, so people want to see stuff in game, and people want to see stuff for linear if you're applying to a film gig. So yeah, we can go on and on about that. Feel free to my email's up there. We can talk about this more for sure. Let's see. I've heard when considering aesthetics in sound design to consider the following: timbre, tempo, instrument keys, loudest melodies. Is that true? Yeah, for sure. Timbre is, if I play a C note on a piano and I play a C note on a violin, and I said, hey, which is which, you would know which, right? They're playing the same note, the same frequency, but one sounds like a piano, one sounds like a violin. It's because they each have their own inherent timbre, right? So absolutely, if you were to tell me, hey, Travis, I'm going to go make Sharkland VR with the bubbles, the timbre of that bubble, that pop, could live in a million different things at different frequencies, but it's the quality and the timbre of that sound which makes it sound like what it is. Tempo is time, how fast and slow something is. Keys is like, the musical key of the sound, so like C major versus E minor kind of deal. And then loudness, right? Loudness is how loud something is, right? Is it quiet sound, loud sound? We can go into that, a big, huge talk. And then melodies are arrangements of different things in a given key. As a sound designer, I think of more kind of eclectic things, like fuzzy, warm, dry, wet, crunchy. Like those are more designy terms for me. I don't usually think of things in terms of melody or tempo, right? That implies an inherent rhythm that I don't really work with, but they're totally, definitely things more on the composing side you'd work with for sure. Let's see. I think I got all the ones I see unless new ones have come up. Oh, cool. Lucas. What's the cost of CPU for spatial audio in comparison to stereo surround? How to make it easier for CPU? Man, y'all are hitting me with questions that we can go on for. That was great. Yeah, off the top of my head, I don't have a number. Like I could tell you that, you're going to have let's say you have 20 sounds in a Unity scene and you're not using any spatial audio. If you slapped in your computer that can, let's say it's a computer from the last 3 or 4 years, 5 years, you slapped 20 spatial audio sources on there, all playing at once, you'll see a sizable, 5 to 15%, somewhere in there, performance hit to the CPU on the audio thread, right? So if you want to make it easier for CPU, you have a million things you can do around only play spatial sounds for the things that I can actually hear. If they're 50 feet away and I'm not hearing them, don't play the sound. Don't render spatial audio. You can take it a step further and say hey, I know I have 30 spatial sound resources. I'm working HoloLens 2. I have 30 sounds. That's it. Maybe you don't spatialize things that are less likely to be heard, not as important for the experience, stuff like that, kind of give and take, right? But that's totally more in the lines of technical implementation, right? That's the design. That's the sound designer wearing the design hat, but implementing it in a creative way. Those are just a couple that come to mind. I think I would definitely recommend in the resources, and again, we will share these, looking at the breakdown of CPU between Resonance, Microsoft Acoustics, Oculus. They all have different pros and cons, including CPU use.
Mm-hmm. All right, let's see what else we got here. I think I saw a couple of ones, and my apologies if you've already answered it.
No worries.
So Yuri, what do you think about audio AR like the extincted Bose project?
Oh man, I think it's awesome. I really, really do. I tried the Bose headphones and I said, hey, this is a really lightweight way for people to get immersive audio on their glasses, right? And I think the best thing about it was that it didn't feel. I wish I have a pair somewhere. I wish they were sticking around because it's made audio more of like the forefront on a piece of technology that kind of for consumers aside from like headphones never really existed, right? It's a pair of sunglasses that has an audio feature, right? So yeah, just my thoughts. I think it's great. I really hope people start going in that direction because the future of mixed reality is getting smaller, it's getting thinner, it's getting faster, right? So just my personal speculation, like we know Apple's going to have something at some point and it's going to be this cool looking set of glasses thing, right? A year, 3 years, whatever. When they do that, maybe, looking at the Bose stuff and all the other stuff people are working on, it needs to be cool. It's got to feel right. People are not sitting on the subway wearing an Oculus Quest, right? It's a hard problem. And I think the Bose folks did a great job of like challenging that from an audio side.
Right. You see anything else that caught your eye there?
Let's see. I'm going to go by not answered. Let's see. Cool. Yeah. Would you say there are any pros and cons from Benjamin here from implementing spatial audio using middleware rather than directly in Unity? Yeah, man. I mean, Wise and Fmod are two of like the big heavyweights for middleware, and they're both awesome, right? They definitely give you a ton of capabilities out of the box without having to write a script. We had to write 7 lines of code to randomize a sound. In Wise, like it literally takes less time for me to do it than I've described how to do it, right? Mm-hmm. Absolutely. And Wise, they have an amazing ecosystem for spatial audio and for acoustics. So I definitely would suggest, if you're making more than like a sandbox experience or, a quick, 2-week prototype, definitely look into these awesome middleware solutions. Microsoft Acoustics implements really nicely with Wise. It's great, right? It's great. Let's see. Are there any artists you recommend to check out that use spatial audio in their music production? Wow. I don't know off the top of my head. I really don't. I listen to a lot of, I love like modular music, right? So like Eurorack synthesizers and stuff. And some of those guys, I'll post some links in the chat or post some links in the resources. Some of those folks, they will record like binaurally, which is essentially, a binaural recording is microphones that are used at the eardrums to give you that perspective as if you were like that person, essentially, right? So if I took those 2 mics I had and I put them here and someone like walked in front of me and then I sent you that stereo recording from those 2 mics, it would sound like, whoa, like that person literally walked in front of me. Short answer is no. Sorry, I don't have a good one for you. But that's a really cool question. Pros and cons. I guess, one quick thing about that before I forget, just back to Ben's question about middleware. You just are investing in more when you invest in Wise. Like as the audio person, usually what happens in game dev is you are now the Wise person, right? So if audio breaks and you don't know how to use Wise, that's a little scary than if it was Unity and 7 of your audio or all 7 of your programmers know how to use Unity, right? Doesn't mean you shouldn't learn it though. You should learn how to use Wise and understand it really well. Let's see.
So there's Richard here. He just followed up. So to follow up with the interactive audio portfolio question, do you think it would be better to find silent clips to apply them to or to create your own experiences in Unity?
Yeah, man. Great question. I think nobody will be turned off by the fact that you made your own Unity experience with all the programming and all the, temp art or whatever, and you implemented your own sounds, right? That shows a pretty awesome ability to think from the technical side. So if you're pursuing, an entry-level technical sound role or something more on maybe like the audio programming side, right? Yeah, that's killer, right? If you're more strictly focusing on the design, right? If you're looking at a team that may already have 2 audio programmers and an audio engineer, the linear sound design will show your chops for what you can actually create. So yeah, I think, both are great paths. For someone totally starting out, I think I mean, this is just my own opinion. I'm sure I saw a lot of folks like friends of mine in the chat, and I kind of hope they call me out on this if this isn't true, but I see more like entry-level sound design roles than I do for entry-level technical roles. which tells me there's a lot more people working in entry-level sound design. So maybe you have a better entry point if you can nail the audio implementation side, maybe. Kind of just speculating. If I had to do it again, that's probably what I would do.
Mm-hmm.
Let's see.
What did we miss?
I'm so stumped on that. Artist using spatial sound. That was cool. Let's see. Oh, I'm going to go to the bottom. That seems like there's like more questions down there. Let's see. Why are you scrolling without me? I'm not scrolling. Hi, how is XR different from MR? It's just a nomenclature, right? Mixed reality is Microsoft's approach to like the spectrum, right? And I think XR it's the same word, right? It's mixed reality. They're just written differently. Let's see.
So there's one here in the chat, not on the questions tab. It's how would you go about recording live performances in XR? Is there special recording equipment to get spatial audio?
Yeah, cool question. So a couple ways you could do that. I think, so just to touch on it really quickly, an ambisonic mic is essentially 4 microphones that capture the positional information of where those sounds are in space. Right? I'm summarizing a thing in like 2 seconds. But so let's say we have a campfire scenario where Johnny's playing guitar, Melissa's singing over there, and we have some dude like banging a drum like he knows what he's doing, right? You could put an ambisonic mic in the middle of that space, right? And that ambisonic mic is not only going to capture the audio, obviously, but it's going to capture all that positional information because you have different, with the 4 microphones, you have microphone 1, 2, 3, and 4, all capturing the sound, but capturing all that information to say what's different between the 4 of them, right? You can then take that ambisonic recording, throw it into Unity, and can essentially Unity can do some work to say like, okay, I know the position of this stuff. So as you turn your head, it will sound like where those musicians are at, right? I'm summarizing a lot of steps in there, but yes, it can be done and it's awesome. Definitely check out like Oculus Venues. So they use ambisonic recordings all the time for like some of their basketball games and stuff. It sounds great. They do a great job. The other way is if you actually use like microphones like this one on my desk and recorded point sources, right? Like we were in Unity, and you can actually place them with the spatializer and play them based on where they're positioned, right? You can do that as well.
Perfect. All right, so there's this new one by Alden Braverman. He says may not be related, but figured he'd ask. Are you familiar with any real-time source separation frameworks for XR? I think NVIDIA might have had an initiative with their RTX processing.
Yeah. They just released this thing that's super, super killer. So if I'm understanding your question properly, I believe you're talking about like real-time source propagation amongst like different sources, like how we can use machine learning to parse different sounds at a given, like in real time, right? Yeah. So NVIDIA is letting you do like NVIDIA right now. If I got the latest NVIDIA driver and this like little plugin they made, the name is slipping me. You can actually turn a fan on like right next to your head and be talking, and it will parse out your voice. That stuff is super cool. Your phone does that too, by the way. Like your phone basically has a bunch of mics essentially. Well, sometimes they have one mic, but has some DSP, some signal processing in there that'll parse out. I think I keep saying parse, like determine like the most important information based on the frequency and know what it is, and it'll essentially do noise cancellation to block out that information, right? Bose headphones, all the Bose headphones are doing is taking in the frequency of the outside world. So like usually it's an airplane hum, a very low airplane hum. They're flipping the phase, right? Flipping the amplitude so that it cancels out, and then you don't hear anything. That's another awesome like use of real-time stuff. As far as like how it's going to get to XR, we're still working with like pretty tricky output scenarios, meaning, in my opinion, like the highest quality headset sound right now is still on the Quest, right? So we have these little tiny headphones like somewhere in here. Until the budget for like headphones go up and people aren't trying to not pay $400 for a headset and we can afford to have really good drivers, that's going to be harder and harder because you don't have as much, frequency width to parse out anyway. Like it's not like you would be getting a hum on the Oculus Quest below 200 hertz because you couldn't hear it. So Again, a long answer to your question, but absolutely, the NVIDIA folks are doing some great work there for sure.
Wonderful. Now, did you happen to answer a question about DJ mixing table?
Oh, I didn't see that. I didn't see that actually.
All right. So this one from Eric is there a way to implement sound effects similar to the ones of a DJ mixing table in Unity? I don't think the audio middleware stuff is capable of doing that. Are there some out of the box solutions?
Cool. Yeah. Just so I understand, like sound effects out of them, like if I was going to be like, doo-doo-doo, right, like kind of like play a horn or something, you could totally do that, in the box, in Unity or in Wise, right? Just so I understand, like I think the example you're describing is if I, made this virtual DJ console, and I literally could attach buttons, just like we were doing, right? Attach buttons to those sounds. We can make a soundboard component. We can make like this holographic button thing that when you press those buttons, instead of playing an audio source at that position, maybe it plays out of the whole room so that everybody can hear it loudly, right? But totally, yeah, we could totally pull something off like that off. For sure. I would definitely recommend, like, if you need to take it a step further and like network the audio, pull on someone who understands like networking a little bit. I don't know anything about that stuff, so I'm a little useless there, but because I'm assuming you're going to want that experience different for, a room of people. But yeah, you could totally do that for sure.
Right on. Cool. Well, let's wrap up with a couple more questions here. Cool. Jessica Berg, a minute ago, is it possible to record and share a live concert performance in real time via AR, VR, or does it have to be pre-recorded? Waves VR seems to be trying.
Yeah. So, we did a lot of like live performances when I was working on AltSpace stuff. So we had Reggie Watts in there, playing live. Thousands of people came to those events, this is like 2015, right? And we had, over 300 live DJ events. It could totally happen. It's totally possible. At the end of the day, like latency is a bitch, right? So we have this like fundamental physics problem of putting multiple people in a space together, in a virtual space together and having that stay in sync. That's really, really hard. The DJ solution's a little bit easier because you have one specific person at one specific place just sending audio out.
Right.
But yeah, I definitely, recommend, like you called out the Wave. Like, first of all, I think the Wave is doing like some of the coolest work in the space. I think they do an awesome job of making these pretty insane experiences. But they're hitting a lot of the challenges, some of the other VR startups are hitting, or other VR companies are hitting, of just like networking people and keeping that quality really high so that you could send really high quality audio while also rendering like 30 people in a room or 100 people or 1,000 people in a room off of essentially something that's the same processor as your cell phone, right? So absolutely. I think the one caveat there is latency is really hard. And there's a reason why you don't have like Twitch streamers jamming with each other just on a regular, jacked in Ethernet cable, having one person play guitar in Bangladesh and one person playing drums in California, right? There's a reason that doesn't happen yet. And it's even harder if you try to do it for VR, right?
Right. Alrighty, well, let's conclude with this one last question from Eric again. Do you have recommendations for using audio effects in Unity, especially for music output?
Yeah. Honestly, man, I'd pull in Wise. I would honestly pull in Wise. But if you're strictly thinking music output, you're gonna have to do some sort of. You might have to do some sort of like streaming over like a VoIP codec, which is not fun because the quality gets kind of slammed. I guess I don't really have all I need to answer it fully, but assuming things are staying local, you can just play audio right out of the box. If you're playing a stereo file in Unity, there's not enough for that. There's not enough things happening there for like Unity to change too much, right? It's where you start losing things like over the networking, and it's where where that cost comes in and where that quality change comes in. Obviously, as you add in like spatial audio capabilities, it gets a little bit more complicated. But in terms of like specific tools to stream music out of Unity I don't have a great answer. Things like what's the VoIP, like Coherent UI. I know they were doing some audio stuff with like networking audio packets, but the quality wasn't great. I think it's just like, that's grabbing some engineers and like a bunch of C#, and getting the networking working. Unity would be enough. The reason I say bring in Wise is because Wise has some some great resources for like high quality streaming, right?
Right.
Like Call of Duty, I'm sure like all those big games that do all that really high quality voice chat, they are probably, I'm making a bit of an assumption, but they're either using some really proprietary high quality stuff, or they're, using Wise's native stuff to make that really great.
Beauty. Well, hey, Travis, thank you so much for your time today. Truly a pleasure and an honor to have you. The man, athlete, XR and sound professional, Travis Fodor, everyone. Thank you so much again. Pleasure to have you. Hope to have you with us again, leading another one of these sound workshops. We got the chat going off here. Everyone's thanking you. So pleasure again. So if there are any questions that we may have missed or not have answered, please don't hesitate to reach out to Dayon, myself, even Travis. Check out Travis's Twitter page, his YouTube channel. Follow him there for all the exciting stuff he's working on. But again, Travis, pleasure to have you. Really appreciate your time today, and hope to have you with us again.
Of course. Thanks so much, man. This has been a blast. Really appreciate all the questions and all the help you guys are doing. Thank you again.
Anytime. Again, guys, feel free to reach out if there's anything we could help you out with. But Travis, take it easy. Thanks again. And thank you, everyone, for tuning in for another Circuit Stream workshop and webinar. Catch us next week, the weeks after. We have a bunch lined up. And I wish you a wonderful evening, morning, night, wherever you are, if you're still up. And take it easy. Thank you again.